Okay, good morning. Let's start the class. Today we'll be doing the fifth day of polynomials and like the attendance is really good, but I didn't expect this much to come because it's a postponed OA day and like even though we're having the both classes here, I still didn't expect to have this kind of attendance today. So it's really good. Keep that discipline from the day one. So then it's easy to do a science stream subject or like A-level math. It's easy to do that if you practice the discipline and if you have this throughout the 2 years, it's really good. Because normally if I put online class to other batches in 2025, 26 in a POE day, that what we don't do. But I'm pretty sure, but if I put online class, the attendance might be really less. But here we have like if we consider the addition, the sum of the both classes, the number of students in both classes, and we have roughly around 5/3 of the both classes are here. So that's really good in and especially a main POE day. Okay, so today we'll be doing polynomials, and I told you that normally I don't do classes in the main POEs, Vesak, Poson, and SLA, but we had to do this is the reason is because you know that both English medium classes we have to give holidays because of the Vesak. And again, Poson even came on Tuesday, so it's not practical to give that much of holidays, and because we need to catch up with the single medium class. So in the single medium classes this week, we finished polynomials. So today I'll be doing the day 5 of polynomials, and then let's cover the word. Okay, so I'll start with the homework question. I gave this question, the 2011 A-level all syllabus question as homework. I gave it as homework. I have marked that I have given it as homework. Can you just confirm it whether I gave it as homework? 2011 all syllabus. I gave it, right? Yeah, okay. So I'll start from there. And anyone who couldn't do it, the homework, you can just start work with me. Okay, let's start with 2011 all A-level all syllabus. So here it's question number 40. Clear? Okay. And I need you to respond in the chat. Okay, when I ask questions, I need you to respond in the chat. There's no matter that you have to consider whether others might see your messages. No, it's only you can only message me, the host here. So I need you to be interactive. When I ask you questions, I need you to answer. Clear? Okay, so here we got they ask you to find lambda and mu when x minus 1 and x plus 2 are factors. Okay, so that is what we got. And what is the polynomial? It's hx, which is equal to x to the power 4 lambda x cube minus x squared plus mu x minus 2. And they have given that x minus 1 and x plus 2 are factors. So since x minus 1 is a factor, since x minus 1 is a factor, x minus 1 is a factor, what can I write? I can write that h1 is equal to 0, which gives me one simultaneous equation. I can write h1 is equal to 0. When h1 is equal to 0, that is 1 plus lambda minus 1 plus mu minus 2 is equal to 0. These two cancel off. I get one simultaneous equation that lambda plus mu is equal to 2. And then what is the other factor? X plus 2 is a factor. The other one, x plus 2 is a factor. When x plus 2 is a factor, it's h minus 2, which is equal to 0. Then I can consider minus 2. If I put minus 2 to the power 4 plus lambda times minus 2 cube minus x squared is minus 2 squared. So I'm doing a homework question. Plus mu into minus 2, again minus 2 is equal to 0. So minus 2 to the power 4 is 16 plus 16, and this is minus 8 lambda. Minus 2 squared is plus 4, but there is a minus in front, and we got 2 mu, minus 2 mu, minus 2 is equal to 0. Clear? Okay. Then when you simplify this, when you take these two to this side, it's 16 minus 4. minus 2 is 10. So I get 10 is equal to 8 lambda plus 2 mu. Okay. Then you can simplify this by 2. You can divide this by 2 and get the answer that O lambda plus mu is equal to 5. So I got two simultaneous equations. So this is equation number 1 and this is equation number 2. Then you can solve them easily. 2 minus 1. I'll consider 2 minus 1. So 2 minus 1 is 4 lambda plus mu minus lambda plus mu is equal to 5 minus 2, which gives me is equal to 3. Okay, then I get 3 lambda is equal to 3, which means lambda is equal to 1. 3 lambda is equal to 3, which means lambda is equal to 1. And then when lambda is equal to 1, it is clear even mu is equal to 1. 1 plus mu is equal to 2, which gives me mu is equal to 2. 2 minus 1 is 1. Okay, so I get two variables, lambda and mu. And the next one is that they're asking us. The next one is that they're asking us to factorize this one. And so otherwise find the other quadratic factor. We have to factorize this. So what can we do here? Look at this. Like if you consider, like we have two factors. I know that x minus 1 is a factor. Okay, x minus 1 is a factor and x plus 2 is a factor. So I know those two. So when I know x minus 1 is factor, to find the other factor, what I normally do, I can divide the polynomial by x minus 1 to get the other factor. When I know this factor to get the other factor, I can divide the polynomial by this factor. But in this case, I know two factors. In this case, I know two factors. So I know two factors. So what are the two factors? X minus 1 and x plus 2. So if I ask you to write fx, look at this. If I ask you to write fx using factors, you can write fx is equal to, we have x minus 1 as a factor, x plus 2 as a factor, and then we have the other factor. I'll take it as gx. Okay, so here it is clear. The degree is 4 here. Here the degree is 1. Here the degree is 1. Then tell me what is the degree of gx. Here the degree is 4. Here the degree is 1. Here the degree is 1. Then tell me what is the degree of gx. I need answers. What is the degree of gx? It's 2. Clear. I need answers. Answers means like I need proper answers. You need to send me in the chat. Okay, so what is the degree of this one? It's 2. It's 2. Clear. Okay, then this is the quadratic factor that they're asking. Because the degree 2. So if the degree is 2, I know it's a quadratic factor. So this is the quadratic factor they're asking. So you can see, how can I find the gx? How can I find this gx? Gx, the other factor, is equal to fx divided by, when you divide by these two, then you can get the other factor. Clear? Because normally, like how do we find the other factor? How do we find the other factor is when we know one factor, we can find the other factor. But in this case, I'll be explaining this separately to this at the later part of the class. So this is a 4th degree one. So I know when it is a 4th degree one, when I know one factor, the other factor will be a cubic factor. Because this is degree 4, and if I consider this factor, only this factor, the other factor will be a cubic factor. So I'll explain how to factorize those. But in this case, since we know two factors, okay, understood? Like since we know two factors, you can divide it by both factors to get the other quadratic factor. Clear? So that is what you have to do. Then lambda is equal to 1 and even mu is equal to 1. To get the other factor, I'm dividing hx. I'm dividing hx. I'm dividing hx by x minus 1 and x plus 1. So what is x minus 1 and x plus 1? So I'm dividing this by x squared plus x minus 2. And what is this x squared plus x minus 2? This is x minus 1 and x plus 2. So I'm dividing this by this. So when you divide this by a big factor, you are getting directly the quadratic factor. Clear? So because this is the quadratic factor that they're asking. Okay. And if there's anything unclear, you should ask me. Yeah. Same as in the class. If there's anything unclear, you should ask me. And x to the power 4 divided by x cube is x squared. When you multiply x to the power 4, x cube minus 2x squared. Okay, these two, both of these cancel off. Minus x squared divided by, minus x squared minus minus 2. Minus 2 is plus. So minus 1 plus 2 is x squared. Plus x minus 2. When you divide this by 1, it's x squared plus x minus 2. The division is easier. It's 0. Then you know that fx is equal to 1 factor is x minus 1, x plus 2. And here is the other quadratic factor. It's x squared plus 1. It's x squared plus 1. So they're asking what is the other quadratic factor. Okay, this is the other quadratic factor, because quadratic factors are when the degree is 2, we call it as a quadratic factor. Clear? Okay. So I did the 2011 question which I gave as homework. So in past papers so far we have done 2018, 2019, 2024. And 2013, I gave it as homework. Hope you have done it. 2011 old syllabus, 2005. So these questions we have done so far. Let's do more questions today. Okay, let's start the 1980 A levels question. First question under past papers, question number 1. Do the 1980 A levels question. You can do it. Do the work and find the value of Q and send me the answer in the chat. Start with 1980 A levels. Question number 1 under past papers. You can do it, and when you get the value of Q, send me the answer in the chat. Well, yeah. So we are getting, initially you are getting 3 answers. I'll start the question and then let's do the next part. So here, so they have given x minus q is a factor. They have given that x minus q is a factor. Okay, so when x minus q is a factor, so what can we consider? That f minus q is f not minus q, f q is equal to 0. Okay, so here, what is the polynomial fx and so this mark you can see in this table, they have typed this as 3 with 3 small straight lines. So we know normally when we say equal, that we only use 2. But there is a mathematical definition of using 3 marks, that is identical. But later we'll be learning what are identities. So this means that it is identical, or later I'll explain what is an identity. For now, just if you want to write, you can write identical, but that doesn't mean that doesn't make any way that you are doing the question in a different way. Same thing as like you can assume that it is equal and do the question. But it is something more than equal. So that's why we use these 3 letters, that is something more than equal. Okay, so in singular we call it as not samana, sarva samana. Okay. So here then x minus q is a factor, but you can use this equal marker. But now they really rarely use this, but you can use the equal mark. E is a factor. When x minus q is a factor, what I know that fq is equal to 0. So when fq is equal to 0, you get 2q cube plus 3q squared minus 3q plus q is equal to 0. So I get 2 cube, q cube minus 2q is equal to 0. So here when you take a q out, it's 2 cube tq squared plus 3q minus 2 is equal to 0. You know that you can factorize this because we know, like we explained this, when you're supposed to solve an equation, you need to factorize it. When you're supposed to solve an equation, you need to factorize it. So when you factorize this, it's 2q, you can have minus 1 and q plus 2, no? Because you need plus 3q, no? Yeah, okay, so it's equal to 0. So now you have the product is equal to 0, and then q is equal to 0, o 2q minus 1 is equal to 0, o q plus 2 is equal to 0. So here you get q is equal to 0, and here you get that q is equal to half, and here you get that q is equal to minus 2. Clear? But if you look at this, they have mentioned that q is a non-zero integer. They have mentioned that q is a non-zero integer, which means q can't be equal to 0. You can't accept this answer because q is not equal to 0. It's non-zero. And they have mentioned that q is an integer, q is an integer. So when q is an integer, half is not an integer. You can't accept that because q is an integer. You can't accept that answer because q is an integer. So what is the only answer that you can accept is that q equals minus 2. So what is the only answer that we have to consider is that q is equal to minus 2. So even though you are getting 3 answers because of this data that q is a non-zero integer, you have to only consider q equals minus 2. Okay, hands up who got this answer, q equals minus 2. Hands up who got the answer, q equals minus 2. Who separated the answer? Okay, good. And then next one is that we have to find ABC value such that these two polynomials are equal. So now I know q is equal to minus 2. And then now they have given that fx is equal to something like this. Fx is equal to, no, we have to factorize it. Then you have to factorize it. Okay, then factorize it. Fx is 2x cubed 3x squared minus 3x minus 2 because q is minus 2. Okay, now factorize this. And x minus q is a factor. So what is the factor here is x minus minus 2 because q is minus 2, which means x plus 2 is a factor. So what is the factor that we know? It's x plus 2. So when you know one factor, you can write the other factor. You can take the other factor. So what is fx? It's equal to x plus 2 times what is the other factor? Write it x squared, x and the constant. So here it's 2, which means x into this one should be 2. And the constant is minus 2. How do you get minus 2? It's plus 2 into plus 1. Sorry, minus 1. How do you get minus 2? It's plus 2 into minus 1. And then if you consider this one, you can see here it's 3. The coefficient of x squared is 3. So from this one, you get a coefficient of plus 4. And that means you need plus 3. You already got plus 4. You need a minus 1. So if that is minus 1, x into this one should be minus. Okay, now when I factorize this, fx is equal to x plus 2. When you factorize this, it's 2x plus 1 and x minus 1. 2x plus 1 and x minus 1. Clear? So this is the factorization that you can take it in this way. Clear? Okay, then I'll give you like 2-3 minutes considering this comparing coefficients. You can remember what did we do in the day 1 of polynomials. What did we do in the day 1 of polynomials? Comparing coefficients. Using that, find this ABC value in the last part. Find this ABC value in the last part. Do we find ABC value in the last part? It's simple, because you can remember in day 1 we did this comparing coefficients. Do that. Okay, so what is the question? They have given that fx is equal to x minus a, 2x minus 1 and x plus 1 plus bx plus c. So what are we supposed to do? That we need to find a, b, c, x plus 2. So x plus 2. So we need to find the ABC value such that this identity is satisfied. So can you remember at the first day of polynomials, what did we do is we consider when two polynomials are equal, the degree should be equal and the corresponding coefficient should be equal. So based on that, you can remember there were two methods that we used to find these constants like ABC. One is comparing the coefficients, which means you are comparing, you are making, equating the coefficients, you are equating the x coefficient of here and x coefficient of here. You are equating the x squared coefficient here to x squared coefficient of here. Okay, so that is one method, comparing coefficients. The other one is you substitute values, you can remember. Okay, for that purpose, if you can remember, for that purpose, I told you like what can you do is first we have to simplify this polynomial, and then you have to separately show this is x cubed, this is x squared, this is x, and this is the constant. Can you remember? I admit, like I know that even though I say that can you remember, more than half of this class can't remember that one. You know what is the reason behind that? Because normally, if I can remember, normally in grade 10 maths, we got like 30 lessons. Can you remember how many lessons were there in grade 10 maths? Roughly, I can remember there were like 30 lessons in grade 10. Can you remember? Is that like I can really remember that, yeah, it used to be 32 lessons. Okay, 32 lessons. So there are 32 lessons, and then in grade 11, even you got 32 lessons. Same amount, or like in grade 11, it's less amount of lessons. Okay, now let's talk about grade 10. So in grade 10, you got 32 lessons. So forget about school. Let's take a normal class that you're going. So for that class, if you take like normally per year, we got around roughly we got around 48 weeks, but we know there are some additional weeks. So when you collectively consider them, it's around like 52 weeks, no? 52 weeks per week. And if you take that 52 weeks, like if you take out this New Year week, if you take out this week, December last week, and if you take like 2 weeks for 4 days, so roughly there are around 48 weeks that you have to complete in a normal class to complete this 32 lessons. So that means roughly within 2 weeks you have to complete one lesson. So that is what happened. When today you go to the class, you start a lesson, and by next week the lesson is over. But when it comes to A level, you know that today is the day 5 of polynomials. Today is the day 5 of polynomials. Okay, fifth day. Which means like since today is the fifth day, like we have done this lesson for 5 weeks. And there are some lessons that even might take more than 10 weeks. For example, trigonometry, the first part take around 8 to 10 weeks. And differentiation, the lesson that we are starting in 2026 batch next month, it normally takes around 10 to 11 weeks. And there are big lessons. And even in physics, you are doing still units and dimensions. The second lesson is called mechanics. And that mechanics lesson, normally in the tuition class, it might take more than a year to complete that lesson. A year. At least 10 to 11 months. In some classes, it might take a year, but normally at least we need 10 months to cover that lesson. But in that lesson, that there are 12 subsections, so that doesn't mean the same lesson will be dragging for 10 months. There are 12 subsections, if I can remember 12 subsections. So it comes in vectors, forces, and there are some subsections. So normally it takes that much of time. So you need to have this practice. So that's why, even though I mentioned you have to compare the coefficients or equating coefficients, this method, half of the class can't remember that. That is because when the lesson like lesson lasts for like more than 3-4 weeks, you keep forgetting the initial parts. That can't happen. You should have this practice. If you can develop the small discipline from day one, then it's really easy to do this maths. Okay. Okay, good. So here, then I need to simplify this and get the coefficients separately. Okay, then simplify this. When you simplify it, you get 2x squared. 4x minus x is 3x minus 2 plus bx plus c. And then fx is equal when you multiply 2x cubed, 3x squared, minus 2x, minus 2ax squared, minus 3ax, minus a into minus 2 is plus 2a, plus bx plus c. Then fx is equal to 2x cubed. When you consider the x squared separately, you have 3 minus 2ax squared. And if you consider x, it's minus 2, the coefficient here. Here it's minus 3a, and we got a b here. And what is the constant? It's 2a plus c. So I have separated the x cube, x squared, and constant. X cube, x squared, constant, and x. So this is x. So if you look at my simplification, you might have noticed something that when I'm writing this step, when I wrote this step, you can see that I have put a small mark of some of the terms. So what did I do? Like when we have, let's say we are having like a big number of terms, like we have 8, 9 terms. And when we are coming down to the next line, there is a high possibility of you missing some of the terms. Let's say that we are having like in an expansion, we got like 10 terms. And when you are writing the next line, there is a high possibility that because we are humans, no, we do human errors. So there's a high possibility that you might miss some of these terms. So there is a high possibility that you might miss some of the terms. Clear? So that's why I'm just doing this in this way. When I'm writing something in this way, I just put a small mark that I have considered it. So I have considered this one, I have considered these two, I have considered these three, and then we have this one 2a plus. Clear? Okay, clear. Okay, then we are talking about comparing coefficients. Now we have to compare the coefficients with fx. So what is fx? So this is fx. So this is fx, and we got q is equal to minus 2. So when you compare coefficients, so using this one, and now I'm going to compare coefficients. So how can you compare? When you look at the x cube, there's nothing that you have to do because x cube both is 2, so nothing to do. Go to x squared. When you consider x squared, here it's 3 minus 2a is equal to what is the x squared coefficient here? It's 3. So minus 2a is equal to 0. You get that a is equal to 0. Clear? You get that a is equal to 0. I get it. A is equal to 0. And then when you consider the next one, x, it's what is x is minus 2 minus 3a plus b is equal. What is the coefficient of x here? It's minus 3. And I know a is 0, so minus 2, it's 0, you do not write it. It becomes 0. If you want to write it 0, I take this minus 2 here. B is equal to minus 3 plus 2. So B is equal to minus 1. We get that B is equal to minus 1. Clear? And the last one, consider the constant. If you consider the constant, what is the constant? That 2a plus c is equal to, what is the constant here? Minus 2. So a is anyway 0. Then I get that c is equal to minus 2. Okay, so you can find that the a, b, c values such that this identity is satisfied. You get a equals 0, b equals minus 1, and c equals minus. Clear? Got it. So same thing that what we did in grade 1, in day 1 of polynomials. I just simplified this and I arranged this in a proper way that I can see the x squared coefficient, x coefficient separately. Okay, then after this, do the 16th question in past papers, 2012 A-level whole syllabus. After this, do Q16. Same question, identical question. 2012 A-level whole syllabus, and in the chat send me the answer. Okay. So I'll give you time to do the entire question. In the chat send me the answer. Okay. Okay, continue. Please first complete this and then do 2012 A-level whole syllabus. Okay, so I saw that you have given answers good. The 2012. So you can see that it's like the same question, only they have changed the values, you know. So that happens in A level. Some of the questions like get repeated, even though it's from 1980 and then 2011 after 32 years. There might be a repetition of some of the questions, and sometimes it happened in this way that you are getting the exact question. Not even a letter or number has been changed. For example, in this year's paper, 2024 paper, so we have this differentiation part. So in the differentiation question was the exact question that what we got in 2006. Same question. Same question. The only thing that they have added an additional expression to be proved. That's all. That happens. It happens in ALs. Even though we say that it's A level paper that it's 100% fresh and new, but there are sometimes previous year's questions has been repeated. Okay. Okay. So 2012 whole syllabus. 2012 A level. The whole syllabus. So here they have given that fx is equal to is identical, but you can just use this equal mark. 2x cube minus x squared plus minus 2x plus k. Okay, and they have given that x minus k is a factor. X minus k is a factor, which means fk is equal to 0. If k is equal to 0, then 2k cube minus k square 2k plus k is equal to 0. 2k cube minus k cube minus k is equal to 0. So when you take k out, it's 2k square minus k minus 1, which is equal to 0. So this get factorized in a way that minus 1, you know, you need minus, so minus 1 and plus 1. Same drill. Make each factor equal 0, or 2k plus 1 equals 0, or k minus 1 equals 0. So here we get that k is equal to minus half, and here I get a proper answer, an integral value that k is equal to 1. You can see same thing, they have given that k is a non-zero integer, which means you can't accept this answer because k is not equal to 0, and you can't accept this answer because k is an integer, which means the only answer is k equals 1. Okay, hands up who got the answer k equals 1. Hands up who got the answer k equals 1. Everyone should get the answer. Like same drill, same thing. Everyone is supposed to get the answer. Okay, then you can factorize this. For this purpose, they're asking to factorize this. So when I factorize fx is equal to 2x cube minus x squared minus 2x plus k is equal to 1. And I know that x minus 1 is a factor. X minus 1 is a factor. Because x minus 1 is a factor, then you can find the other factor. But one factor is x minus 1, then the other one will be x squared, x and the constant, since it's 2 here. So here, but you can't say it's 2, it's 2 here. So here it gets 2x squared. And we should leave plus 1. How do you get plus 1 is minus 1 into minus 1. And then the coefficient of x squared here you can't see because of the light. Yeah, so here it's minus x. So here you can see, it's minus x cube squared. So here we already got minus 2. And since we got minus 2, so here what we require plus 1. Minus 2 plus 1. And then it is plus. Okay, then you can furthermore factorize it to get that fx is equal to x minus 1. 2x minus 1 and x plus 1. So you can factorize this and this way. Clear? Got it. The second one, an identical part that they are asking to find ABC value such that fx is equal to x minus a, 2x plus 1, x minus 1, and dx plus c. Identical question. Okay, so same thing first. Simplify this and properly rearrange it. X minus a. So when I multiply, it's 2x squared minus x plus x is minus 2x plus x is minus x minus 1 dx plus c. So this is equal to 2x cubed minus x squared minus x minus 2ax squared plus ax plus a, because minus a into minus 1 gives you plus a plus bx plus c. Fx is equal to 2x cube, and then same drill. I took this one, so I'll take these two, minus 1 minus 2a x squared, and then x, it's minus 1, and here we got a, and here we got b, and then the last constant is a plus c. Okay. So after rearranging this, you can compare coefficients. We call it as either comparing coefficients and equating coefficients. It's the same. We call it as comparing coefficients and equating coefficients. Same. So here, if you consider x cubed, there's nothing to be compared. 2 is equal to 2. You write x squared. It's minus 1. Minus 2a is equal. What is the coefficient here? It's minus 1. These two cancel off. A minus 2a is equal to 0. Same as before, you get a is equal to 0. Same as before, that a is equal to 0. And then when you compare x, it's minus 1 plus a plus b is equal to the coefficient here, it's minus 2, but I know that a is 0. So when you take minus 1 here, you get minus 2 plus 1, which is b is equal to minus 1. A equals 0, b equals minus 1. And then if you make the constant equal or compare the constants, you get a plus c is equal, what is the constant here? So here the constant k is 1 with plus k. It's equal to 1, and simply a is 0, which means c is equal to 1. So I get the answers: a equals 0, b equals minus 1, c equals 1. Hope you got the answer for 2012 A levels. Okay, so this happens in A levels. Sometimes there might be a possibility of father doing the question in 1980 A levels and the son is doing the question in 2012 A levels. That happens. And like there's a small difference. No, Q has become K and the answers are slightly different. But I told you there are some instances where the exact question has been replicated. So there might be a chance that the father and son is doing the same question in their respective years of A levels. Clear? That can happen. Okay. Okay, then now look at this. Come back to the Tude's questions and think of how you can do question number 23. Question number 23. So there's a normal way that you can do it. It's okay for now if you take the answer in that way. There's a normal way that you can do this. A polynomial has been given, and then you have to divide. You have to find the remainder when divided by x squared minus 1. There is like you have to just find the remainder when divided by x squared minus 1. Look at question number 23 in the Tude, not the past papers. Q23. So how many marks does this question carry? Normally in a A-level nowadays, polynomials question, polynomials comes with these quadratic equations. So the entire question consists of 150 marks of your PO paper out of 1000. In that one, normally polynomials get around 60 marks. So you can say a polynomial questions nowadays is like 60 out of 1000. You might feel that 60 out of 1000 is something that really less value. That is like one out of 20 of the paper, but you can't say it that way because that is how you are going to collect marks. That is how you have to collect marks, like mark by mark, lesson by lesson. Okay. Okay, just do this question number 23 in the way that you normally know to do. We have to find the remainder when fx is divided by x squared minus 1, which is not a linear factor, linear divisor. Okay, so I told you like there is a normal way that you can do this simply by dividing using long division. You can do this. Okay, like using long division, you can do this. So that is the normal way when you divide it by x squared minus 1. When you divide it by x squared minus 1, you get the remainder. So that I admit, but that is not the way that I'm going to explain now. I'm going to do it in this way. Okay, so that is the general way. Anyone in the class can just divide it by using long division and get the answer. If I can remember, you got a remainder like minus 4x plus 6. Hands up if you got it. I remember something like getting an answer like that, minus 4x plus 6. Okay, so it's clear you have got that answer. So how can you get it? When you simply divide it using long division, you get that remainder. But that is not the thing that I want to explain here. Is now look at this. Fx has been given as x to the power 5 plus 3x to the power 4 minus 2x cubed plus 2x squared minus 3x plus 1. So this is what they have given as fx. Okay. And now, like the divisor is when divided by x squared minus 1, and I'm taking the remainder in this way. Okay, now look at this. You know, if you can remember, since the degree of the divisor is 2, I told you in general that the degree of the remainder should be less than the degree of the remainder. Sorry, the divisor. Which means if the degree of the divisor is 2, that means the remainder's degree should be either 1 or 0. You can't say it's 1. It can be either 0 or 1. The only thing that should satisfy it, it should be less. So that in that case, if the divisor's degree is 2 is 3, the remainder's degree can be either 0, 1 or 2. But normally, we take the remainder as a degree 1 polynomial. So like when the divisor is degree 2, I told you, the degree can be, the remainder's degree can be either 0 or 1. But in general, we use this degree 1 polynomial to write the remainder. So then I can write that the remainder is ax plus b. Ax plus b. Here the degree is 1. So I'll give a small note that normally when the divisor's degree is 2, we take the remainder's degree as 1. Okay. So here it is clear even this one can be a degree 0, 1 because if a becomes 0, this goes away and only b is remaining. Then the degree is 0. That is okay. So it might be even turned to a 0 degree polynomial. That is okay. Okay. In general, we are writing the polynomial with a degree that is 1 less. There is only 1 less to the divisor's degree. Clear? So if the divisor's degree is 3, we normally write the remainder as a second degree polynomial. Is that clear? Okay. So now when you write it in that way and when you write the division algorithm, fx is equal to this gx. Gx is the quotient that I don't know about him and I don't want him. I'm just writing gx. Then I can just complete the division algorithm. So the only reason that I'm writing gx just to complete the division algorithm. And we got the divisor x squared minus 1 plus ax plus b. The remainder is x plus b. Clear? Okay. So what is fx? Fx is x to the power 5, 3x to the power 4 minus 2x squared, 2x plus 1. Gx times, and I know I can factorize this, it's equal to x minus 1, x plus 1 plus ax plus b. Okay, same drill. You know that gx is someone that you doesn't know, you don't know, and even you don't want him. So like imagine about someone that you don't know about that person and even you don't want him, then you don't have to care about him because you don't know him and you don't want him. Both you don't want and you don't know. So what I do here is like if you consider we have three variables here, three unknown terms here. G is unknown, A is unknown, and B is unknown. But my goal is to find A and B. My goal is finding A and B. And then this is Gx. So Gx is the polynomial that I don't want. So I need to take it out. I need to eradicate Gx. So in order to eradicate, to take out Gx, I can make a factor with him equal to 0. I can make him a factor with him equal to 0. So the square is only in x square. Yeah, divided by x square minus 1. So it's only in the x. It's a difference of 2 square, not x minus 1 square. Okay. Okay, then how can I take out this when you put x equals 1? When you put x equals 1, this becomes 1 plus 3 minus 2 plus 2 minus 3 plus 1 is equal to G1. I don't know about G1. That is okay, even though you know about G1 or you don't know about G1. Someone with G1 becomes 0, so then you don't have to think about it. It's A into 1 plus B, clear. So then you have this one becomes 0. This becomes 0. Then I have these two cancel off. It's 2. And I get A plus B is equal to, here I get A plus B, 1 plus 1 is 2. So I get one simultaneous equation that A plus B is equal to 1. And since I know that I have two unknown terms A plus B, I need two simultaneous equations. How can I take the other one? First you make this one equal to 0, then you can make this one equal to 0. So x is equal to minus 1. If you consider that x is equal to minus 1, I get minus 1 to the power 5 plus 3 times minus 1 to the power 4 minus 2 times minus 1 cube plus 2 times minus 1 squared minus 3 into minus 1 plus 1 is equal to g minus 1. I don't know about g minus 1. That doesn't matter because it becomes 0 anyway. Plus a into minus 1 plus b. Okay, so this becomes 0. And when you simplify it, I get another simultaneous equation. I'll write it here. Okay, so what is the other simultaneous equation? Minus 1 to the power 5 is minus 1 plus 3 into 1 minus 2 into minus 1 plus 2 into 1 plus 3 plus 1 is equal to, this becomes 0. It's minus a plus b. So you get another equation, minus a plus b is equal, and you simplify minus 1 plus 1 cancel off. This is 3 plus 3 is 6. Minus 2 into minus 1 is plus 2 plus 2. You get minus a plus b is equal to 10. Clear? So I get another simultaneous equation. So when I have two simultaneous equations, you can simply solve them. To solve them, 1 plus 2 is a plus b minus a plus b is equal to 2 plus 10, which gives you the 2b is equal to 12, so b is equal to 6. So when b is equal to 6, you can take from the first one, a plus 6 is equal to 2, a is equal to 2 minus 6, and a is equal to minus 4. So, but a and b is not the final answers. The answer that they're expecting from you is the remainder, not a and b. Okay, so a and b is what? Sir, we can't see the bottom most line of the board. This one you can see, you know. That is because in your in this Zoom, if you have this bar, this audio, video, chat participants react to this bar, then the screen is cancelled, but you can take the bar out. Because from my end, I can see this. I can see this like. Okay, so if you can't see that, the reason is that. Okay, so then b is equal to 6 and a is equal to -4. But they ask in the remainder. Okay, we have taken the remainder as ax plus b. So write the remainder. What is the remainder? It's -4x plus 6. Please. So what is the remainder? It's -4x plus 6. Okay, it's -4x plus 6. Okay, done. So this is the way that you can do it, and not like when you get this question, you have the freedom to either use long division or this method, but you will realize the importance of this method when I asking you to do the next question, that knowing this method is really important. Okay. Okay, so write it this way. Write it this way. When the device's degree is 2, when the device's degree is 2, when the device's degree is 2, the remainder's degree the remainder's degree the remainder's degree is 1 or 0. Is 1 or 0. Is 1 or 0. But in general, but in general, we write the remainder. But in general, we write the remainder. But in general, we write the remainder as ax plus b within brackets. Write that. We write the remainder as within brackets a is ax plus b within brackets ax plus b, which is the first degree polynomial. Which is the first degree polynomial. Which is the first degree polynomial. Okay, so why do we write it in that way? So there is a reason. So why I'm writing it that way? Because the reason, when we write it as a first degree polynomial, you know, when a becomes 0, then it becomes a 0 degree polynomial. So if the remainder is at 0 degree, it can be like this turns into 0 degree polynomial. That is okay. Like I understood. If this is in this format, this is degree 1. But if you take out this ax, if you take out this, then there's a constant only. No? So here the degree is 0. But if you take the degree as 0 and write the remainder in this way, there's no any possibility that this will be get converted into a degree 1 polynomial. How can x come here? So there's no any possibility. If you start from 1, that can be 0. But if you start from 0, that can't become again 1. Because this one, there's no any way that like we are getting an x term here. So that is the reason we normally write it as ax plus b. So what did I mention? Like when the device is polynomial is 2, the remainder is polynomial. When the device's degree is 2, the remainder's degree is normally 1 or 0. But in general, we write the remainder as ax plus b, which is the degree 1 polynomial. Clear? That is clear, right? So if the device's degree is 3, will there be any change in ax plus b? Yes. So if the device's degree is 3, then I'm writing the remainder as a second degree. So the remainder can be 0, 1, 2, but I'm writing as a second degree polynomial. So then you have to write the remainder as ax squared plus bx plus c. Clear? You have to write it as ax squared plus bx plus c. So when the degree is 3, we are writing the remainder as a polynomial which is 1 degree less than the device's degree. Clear? Okay. Do this one, and then after this, look at question number 26. So look, do this one, do this in this method. So if you have taken in the same answer using long division, that is even okay, but copy down this and then look at question number 26. Look at question number 26. Okay, now when you look at this, I'll explain this 26 so we can do the next question. So they haven't given a polynomial and they have just mentioned about this fx. So simply they haven't given about a polynomial. You don't have any idea about what is this polynomial. They are mentioning there's a polynomial fx when divided by x minus 1. The remainder is 2 and when divided by x minus 2, the remainder is 3. So that's all they have given. So if you write the data, when divided by x minus 1, the remainder is 2. So what is the data that you got here when divided by x minus 1? I know that the remainder is f1. f1 is equal to 2. The other data when divided by x minus 2, the remainder is 3. Which means what can you write is f2 is equal to 3. So this is the only two data that you can write. Using the given data, this is the only two equations that you can write. Clear? This is the only two equations that you can write. But the thing here is like now they are asking the question, find the remainder when divided by x minus 1, x minus 2. So according to the previous method, like if you are going to use longer division, you could have done it if they have given this fx polynomial. If they have given this fx polynomial, then you can divide it by x minus 1, x minus 2 to get the remainder. But they haven't given this polynomial. So when they haven't given this, how can you divide it? When they haven't given this, okay, so clear, when they haven't given this, how can you divide it? How can you divide it? There's no any possibility that you can divide it. Because what are you going to divide? Like fx divided by x minus 1, x minus 2. So how can you find these terms? So in this method, we need to go with this the method that I just explained. I'm writing when divided by x minus 1, x minus 2, I'm taking the remainder as ax plus b. I'm taking the remainder as ax plus b. Same drill, because I know when the degree of the divisor is 2, the degree of the remainder becomes 1. Degree becomes 1. Clear? Okay, because like there's no any way that you can divide it using long division method. And then if you write this using the division algorithm, gx, here comes the quotient that we don't know and that we don't want, x minus 2, and then the remainder is ax plus b. The same thing, we don't have any idea about gx, and I don't want this gx. I don't want this gx. So fx, then I need to take out that gx. So how can you take out that gx? You can put x equals 1. So here there is no any polynomial to be like we can substitute x equals 1. So it's simply f1. There's no any polynomial that we can just substitute. But previously there's no any polynomial. A g1, 1 minus 1, 1 minus 2 plus a into 1 plus b. So this becomes 0. So the only data that you know from the first one, from the only data that you know, that f1 is equal to 2. So that's what you know. Clear? So previously you substituted the values and simplified this fx and you got a value. But now they have given that f1 is equal to 2. So 2 is equal to, this becomes 0, a plus b. The first simultaneous equation that a plus b is equal to. Clear? Okay, then substitute x equals 2. Substitute x equals 2. when I put x equals to, it's f2. It's f2, which is equal to g2, 2 minus 1 and 2 minus 2. A into 2 plus b. 2 minus 2 becomes 0. And I get 2a plus b is equal to f2. What is f2? It's 3. 2a plus b is equal to 3. Then same thing, same drill, but the only difference, previously, there was a fx that you can substitute this. There is a fx that you can substitute this. Clear? And then when you simplify 2 minus 1, it's 2a plus b minus a plus b, which is equal to 3 minus 2. So 2a plus b gives you 1. So a is equal to 1. So when a is equal to 1, we get from 1 plus b is equal to 2, which gives you that b is equal to 1. But make sure they are not asking a or b. I have used this a and b and write the final answer. The remainder is ax plus b. So what is the remainder? It's x plus 1. What is the remainder? It's x plus 1. Clear? The remainder is x plus 1. Okay. Hands up if you understood that. Hands up if you understood it. If there's anything unclear, you can ask in the chat. If you understood, hands up. If there's anything unclear, you can ask in the chat. Okay. Okay. And good, like we have the same attendance, like only 2 students have left. But stay till I finish the class, because like if you're going to leave in a while and then you have to again watch this recording of the remaining part, good, like I need this attendance till I finish the class, and we won't take that much of time. By 12 o'clock, yeah, we can finish it. Maximum of 12, yeah, we can finish it. Okay, do question number 27. After this, first do this, then do question number 27. Okay, in question number 27, what is the remainder you got? Can you send me messages? Because then I don't want to take time to do that. Same one. That's a question I'll explain. So tell me, what is the remainder in question number 27? Anyone who got the answer, can you send it in the chat? Question number 27. Oh, you want me to do it? So there's a question saying x equals 2. Shouldn't it be 1 equals 2a plus b, because 2 minus 1? No, when no, this is wrong, because it's 2 minus 1 is 1, but like there's no any impact from this term, because 2 minus 2 becomes 0. So when 2 minus 2 becomes 0, this entire term cancel off. So what is the entire term cancel off? So what is remaining here is only f2 is equal to 2a plus b. Clear? So there's no any 2 minus 1 remaining here. So 2a plus f2 is equal to that one. So what is f2? The data I have given that f2 is equal to 3. So then 3 is equal to a plus b. Can you tell me whether you understood it? The student who have asked that question. Okay. So question number 27, same thing, same drill, and you are supposed to get this remainder in question number 27. The remainder should be 3x over 2 plus 5 over 2. Because the data have given that when divided by x plus 1, the remainder is 1, which means f minus 1 is 1. The same thing if you do question number 27. when divided by x plus 1, the remainder is 1, which means f minus 1 is equal to 1. And when divided by x minus 1, the remainder is, they have given that the remainder is 4, which means f1, sorry, is equal to same thing. And then you're supposed to find the remainder when divided by x squared minus 1, which is x minus 2, x minus 1, x plus 1. Then you can write this as x plus 1 and x minus 1. Clear? And find a and b. You're supposed to get this 3x over 2, 5 over 2. Okay. Hands up who got that remainder. Hands up who got that remainder. Everyone who got this remainder. You are getting a fractional answer. Hands up. I just want to check it. So if you got the answer, just hands up. Okay. 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 So then let's do another past paper question. Look at start 2014 A levels question. You can find A and you can complete up to line number 2. Start 2014 A levels. So after this one, start 2014 A levels. Start 2014 A levels. Do the 2014 A level question. Question number 18 in past paper. Find the value of A and come up till line number 2. Find A and then factorize it. Find A and then factorize it. So can we keep it as decimals? It's okay, but normally when we are writing the coefficients of a polynomial, we keep it as fractions. Because like when you write 2.5 x squared, it doesn't sound in a usual way. So better to keep fractions, okay? Like let's say your final answer is 5 over 2, like you are already getting a numerical answer 5 over 2, it's okay to convert that into decimals. But when you are writing it as a fraction, like sorry, as a polynomial, 2.5x, like it doesn't sound good. So it's better to keep as fractions, okay? We can do 2014 A levels. Okay, so here, like when you take the question 2014, they have given fx is equal to 3x 3x cube. Sorry, fx is equal to 2014. Oh yeah, 3x cube 5x square plus ax minus 1. Okay. And then 3x minus 1 is a factor. So we know that 3x minus factor is a factor. Then what can you write? You can write that f1 over 3 is equal to 0. f1 over 3 is equal to 0. So how do you get this 1 over 3? Is when this becomes 0, 3x minus 1 becomes 0, x is equal to 1 over 3. So that I have bit. Clear? Okay, so here then when you put 1 over 3, it's 3 into 1 over 3 cube plus 5 into 1 over 3 square plus a into 1 over 3 minus 1 is equal to 0. So when you simplify this, it's 1 over 27, 1 over 9 plus a over 3 minus 1 is equal to 0. 1 over 9 plus 5 over 9, a over 3 minus 1 is equal to 0. So when you simplify this, if you take, I'll do the simplest way to simplify this. If you take 9 as the common denominator, it's 1 plus 5, which is 6, plus this multiplies by 3a minus 9 is equal to 0. Multiply by 9, so 1 plus 5 is 6, minus 9 is minus 3, you get the answer that 3a is equal to 3, that a is equal to 1. Clear? So you have got the answer, so you should get this answer that a is equal to 1. And then you have to write fx in this given format, which means you have to factorize it. Okay. Okay, so when you factorize fx, so now what is fx? It's 3x cube 5x squared plus a is 1, so x minus 1. And since 3x minus 1 is a factor, then I know fx is equal to 3x minus 1 times, write the other factor, it should be a quadratic one, x squared, x as a constant. Since it's 3x cube, but we already got a 3x here. So then this one should be 1, done. The constant is minus 1, you get a minus 1 when minus 1 into plus 1. And here the x squared is plus 5, and so you have got minus 1. So this into this should gives you plus 6, because you get plus 5 with minus 1 and plus 6. Okay, then to get this plus 6, this one should be 3 into 2 plus 2. And now it is clear what is the format that fx is equal to 3x minus 1 into x plus 1 squared. So if you have done this properly, this is the format they are asking, the way that they are asking to keep this in the format of 3x minus 1, x plus k squared, x plus k squared. So we have got this format, the format that they are asking us. Okay, hands up who got the answer up to this. Okay, and now you have to just do exactly what are they asking. Now they have asked by writing 3x minus 1 in the above expression in the form of this. So here they are asking us to write this 3x minus 1 in the form of b times x plus 1 plus c. So they want us to write this 3x minus 1 in this way. So we have to find b and c. Clear? We have to find b and c. So how can you find b and c? It's 3x minus 1 is equal to bx plus b plus c. Okay. Okay, then if you consider this x, you get b is equal to 3. And if you consider the constant, you get what is the constant? It's b plus c. It's equal to minus 1. So then b is 3, which gives you that c is equal to minus 4. C is equal to minus 4. Okay. So what did I do? Like they asked me to write this 3x minus 1 in the form of this. So then you can get that 3x minus 1 is equal to what? What is b? It's 3 times x plus 1. C is minus 4. Clear? So I'm doing exactly what they are asking me to do. Just write this in this form. And if you realize, like they have asked, we have to write the 3x minus 1. We have to write this 3x minus 1, which is in this expression. We have to write this 3x minus 1, which is in this expression in the form of that one. So they are not asking you to write this 3x minus 1 somewhere is in your next node. We have to write this 3x minus 1 in this equation. So now what can you do? You can substitute this 3x minus 1's expression inside here, because they are asking you by writing 3x minus 1 in the above equation, not anywhere else. In the above equation in the format of this. Okay. Okay, now then I'm going to substitute, look what happens. I'm going to substitute, look what happens. I'm having something like this, look at this. So now fx is equal to I'm replacing this 3x minus 1 by this. I'm replacing this 3x minus 1 by this. 3 times x plus 1 minus 4 times x plus 1 square. So what did I do? I have replaced this 3x minus y by 3x minus 1 by this. Clear? Okay, so here, now when you simplify this, 3 times x plus 1 cube minus 4 times x plus 1 square. 3 times x plus 1 cube minus 4 times x plus 1 square. Clear? So this is what you get. Clear up to this point? Can you just mention, like, send me a message whether this is clear up to this point? So what did I do? I replaced that 3x minus 1 and then I simplified. Okay, everyone send me a message. Everyone, I need to check whether you are properly paying attention. Everyone send a message mentioning whether it is clear or not. Like okay or like anything. At least the emoji, everyone. Okay. Okay, clear, get it? Okay, good. So here, now, like what I want you to understand is in this. Now let's say that I'm asking you to think of this fx using the division algorithm. So if you think about the division algorithm here, I know this is the dividend. This is the dividend. This is the divisor. And if this is the divisor, this becomes the quotient. The one who is with the divisor, it's the quotient. And then I have the remainder here. So if you look at this in terms of a remainder algorithm, a division algorithm, this is the dividend, this is the divisor, and the quotient and the remainder. So this is simply the division algorithm. Okay, now tell me, if I write that A is equal to B into C plus D, and if you think that this is the division algorithm, where A is the dividend and B is the quotient, C is the divisor, and D is the remainder. C, D is the remainder. Okay. Clear? Okay, now look at this. Now, if I ask you to tell, like, how can you read this division algorithm? You can say when A is divided by C, the answer is B and the remainder is D. So if I ask you to read this out, how can you read this? When you divide A by C, the answer is B. The quotient means the answer is B and the remainder is D. So that is clear. Okay, when A is divided by C, this is the answer, the remainder is D. Okay. So if I ask you to read this in that way, how can you say when fx is divided by x plus 1 cube, the answer is 3 or the quotient is 3 and the remainder is this. And this is the remainder. What is the remainder? Minus 4 times x plus 1 square. If I ask you to read this in terms of this division algorithm, how can you read this? When fx is divided by x plus 1 cube, the answer or quotient is 3 and the remainder is minus 4 times x plus 1 square. Now look at the question. The question what they're asking is find the remainder when fx is divided by x plus 1 cube. Clear? Find the remainder when fx is divided by x plus 1 cube. What is the remainder? This is the remainder. Then you can write remainder when fx is divided by x plus 1 cube, it's equal to minus 4 times x plus 1 square. It's equal to minus 4 times x plus 1 square. Clear? So that's the remainder. If they ask what is the quotient, what is the answer, then the answer is 3. The remainder is this. Clear? Hands up if that explanation is clear. So I try to explain in the simplest way. So I told you like we'll be finishing by 12 o'clock. So I see some students have left, but that can't happen now. Just stay, like it's only like 40 minutes more. I'll be finishing by 12 o'clock. Okay, hands up if you understood this explanation, everyone. Hands up. Okay, okay. Then after this one, come up to here and then write this and get the answer. Get the answer, then I'll give a similar question. I'll give a similar question. Okay, then write down this question. Write down this question. If x minus 1, write it within brackets. Write x minus 1 within brackets. If x minus 1 is a factor of, if x minus 1 is a factor of, write this, look at the board, fx equals x cube minus 3x plus a. If x minus 1 is a factor of, fx equals x cube minus 3x plus a, find a, find a, find a. Okay. Okay. Then factorize fx completely. Then factorize fx completely. Factorize fx completely. Okay. Okay. By replacing x plus 2, by replacing x plus 2 in fx, by replacing x plus 2 in fx, by m times x minus 1 plus n, by replacing x plus 2 in fx, by m times, look at the board, m times x minus 1 plus n, m times x minus 1 plus 10. Find the remainder. Find the remainder. Find the remainder when fx is divided by. Find the remainder when fx is divided by x minus 1 cube. Fx is divided by x minus 1 cube. Okay. Okay, do it. Get the answer. Okay, so let's do this. So here, first one, I need to find a. So I just gave this question because I just wanted to do another question in this same concept. So when I consider that x minus 1 is a factor, okay, x minus 1 is a factor. So let's see how it goes. X minus 1 is a factor. So when x minus 1 is a factor, what I can write is f1 is equal to 0. So when f1 is equal to 0, you get 1 minus 3 into 1 plus a is equal to 0. 1 minus 3 plus a is equal to 0. So minus 2 plus a, I get that is equal to 0. A is equal to 2. A is equal to 2. Okay. So then what is fx? Fx is equal to x cube minus 3x plus 2. And you need to factorize this. You know that one factor is x minus 1. So when one factor is x minus 1, what is the other factor? It should be x square x and the constant. So since it's x cube, here it's 1. And the constant I need plus 2. If I want plus 2, it's minus 1 minus 2. And you can see there's no any x square terms here. There's no any x square terms here, which means the coefficient is 0. So, but I already got minus 1 x square. But I want 0. What I want is 0. So then to make it 0, it should be plus 1. Clear? Because the coefficient of here x squared is 0. There's no any x squared means it's 0. We have dealt with those questions. To get a plus 1, it's x into plus x. So then I can factorize fx. You can factorize this furthermore. When you factorize this furthermore, it's x plus 2 and x minus 1. What is the complete factorization of fx? That is x plus 2 I into x minus 1 square. Clear? Okay, hands up who got this question, who have come up to this one. Fx is equal to x plus 2, x minus 1 square. Hands up who have come up to this one. If you got the answer, hands up. I need to check it. Then only I have the understanding, okay, that you have understood it properly. Okay, good. Okay, then what is the question that they're asking is, by replacing this x plus 2 in the expression in this way, so you have to write this x plus 2 in terms of m times x minus 1 plus n. So how can you do it? X plus 2 is equal to mx minus m plus n. Clear? Okay. Then if you consider this x, you have m is equal to 1. M is equal to 1. And when you consider the constant, it's minus m plus n equals to 2, which means minus 1 plus n is equal to 2. Because m is 1, so n is equal to 2 plus 1, n is equal to 3. So you have written this x plus 2 in the format they are asking what is m, m is 1. So it's x minus 1 plus 3, clear? You have written x plus 2 in the given format. What is the format? That is x minus 1 plus 3. And what I have given is that I have given to replace this x plus 2 using this. So what can you do? You can replace this x plus 2 in this expression. You can replace this x plus 2 in this expression. And you get, then you get, look at this. Fx is equal to what is x plus 2? It's x minus 1 plus 3 into x minus 1 square. Now when you simplify, look at this. I saw someone has asked this question, how did it become a cube? X minus 1 into x minus 1 squared is x minus 1 cube. No. When you have a here, a into a squared is a cube. A into a squared is a cube. So when you multiply x minus 1 into x minus 1 squared, it's x minus 1 cube. Plus 3 times x minus 1 squared. So again, consider this as the division algorithm. So when you look at in sense of a division algorithm here, if this is the dividend, here is the divisor, and in this case the quotient is 1. The quotient is 1. And what is the remainder that you got? So that is what they're asking. The remainder is this. So if you explain this in terms of a division algorithm, what can I say? Fx, when we divide fx, so here's a 1 here, you can see. So the coefficient is 1. So the quotient is 1 here. So when we divide when we divide fx by x minus 1 cube, The quotient is 1 and the remainder is 3 times x minus 1 squared. Tell it again. When we divide fx by x minus 1 cube, the quotient is 1 and the remainder is 3 times x minus 1 square. So what is the question that they're asking? Find the remainder when fx is divided by x minus 1 cube. Then what is the remainder? The remainder is 3 times. The remainder is equal to 3 times x minus 1 square. What is the remainder? The remainder is equal 3 times x minus 1 square. Understood? Got it? Okay, good. Okay, complete the work and let's do the last part. Okay, write the last topic. Last topic. Like if you can remember, like normally when I say something in the classroom that I'll be doing this in this particular time period, I make sure from my end to do it. But what happens normally, even though I mention something in the classroom, students can't even remember that I mentioned something. So I have like I'm in a safety zone that inside the lesson that I can say something that I will be doing this in the last day of the lesson, and students won't even ask me, sir, you are supposed to do this one. So like I'm not obliged to do it, but from my end, if I say something, I can like I'm obliged to do it. So from my end, if I say something, I'm like I can make sure that I'll be doing it for sure. For example, even in the 2000 when we are doing in these days in the 2026 class, we are doing velocity time graph. So in that velocity time graph, there is a particular type of question that we can't do. For example, I told you in these polynomials, you can't do the 2022 and 23 questions. The reason is we need differentiation. So differentiation is even yet to do in the 2026 class. So that is a lesson that you will be meeting after year. Okay. So then you can't do that. But if I mention after doing differentiation, I'll be doing that. Somehow I'll be doing that. Even in the 2026 class, now the lesson that we are doing is velocity time graph. There are some lessons in velocity time graph that you won't be able to do properly. Like you can't do it because that we are lacking the knowledge of some of the future parts. But then I say, okay, I'll be doing this after completing it. So somehow I make sure to do it. Okay, so now tell me if you can remember I told you something in the second day or the first day that I'll be doing this in the last day of the of polynomials. Try to remind it, and if you can remember, send me a message. I think it's in the second day of polynomials, not the first day when we were factorizing these polynomials. I told you. No one. So I was asking the question like, can anyone remember that I told you that I will be doing a part at the last day of polynomials? I told it in the second day. Okay, one can remember. He has sent a message. And not the synthetic division, because synthetic division, I told you that is not in the syllabus. I told you synthetic division is not in the syllabus. Anyone who can remember it, you can send it no. Okay, if you can remember, when we were doing this question number 4 and 5, we didn't factorize this fourth degree polynomials. We only factorize the third degree polynomial. Then I told you that I'll be explaining how to factorize a fourth degree polynomial at the end of polynomial. So hope you can remember it. Okay. So make sure like you are the one who's supposed to question me. Like if I leave something, that I'll be doing it at this part, then make sure at least you put a small note. And if I say, okay, we are done with the lesson, then you are supposed to ask me. I like if you ask in that way, say you told that you will be doing this area, aren't you doing it? Clear, because then it is easier. Like let's say because of a reason I forget it. So what happens if I forget it? And there's no one to question me. There's no one to remind me. Okay, so have that habit throughout this. I can remember some of the students asked about that even in the class. Throughout these 2 years, if I mention this part, like I very rarely mention, because normally when I take a lesson, I complete that lesson entire and I don't keep any remaining stuff. But if I say something, that is because of a reason, and you make sure to ask it from you. Okay. Okay. Write the topic factorizing a fourth degree polynomial. Factorizing a fourth degree polynomial. Factorizing a fourth degree polynomial. The topic is factorizing a fourth degree polynomial. Okay. So I'll take a fourth degree polynomial, 2x cubed, 3x squared. Sorry, it's 2x squared. And then minus 2x, minus 3. Okay. So I need you to factorize this. So there are two ways that we can do this. I'll explain both the methods. The first one is the basic step that you need to find one linear factor. So that is the basic step that you need to find one linear factor. Okay, one linear factor. So when you put x equals 1, you can see that it becomes 0. So I can find one linear factor when I put x equals 1. f1 is equal to 1 plus 2 plus 2 minus 2 minus 3. Now you can see it becomes 0. So since f1 is equal to 0, that means x minus 1 is a factor. That means x minus 1 is a factor. Okay. X minus 1 is a factor. So when you know one factor, you can find the other factor. But now I'm having a small issue. What is the issue? Now here, this is a fourth degree polynomial. So when this is a fourth degree polynomial, and here I know the degree is 1, then tell me what should be the degree of the remaining factor. Tell me what should be the degree of the remaining factor. Tell me what should be the degree of the remaining factor. Clear, the remaining factor is a third degree polynomial. It's a third degree polynomial. It's a cubic factor. So I know what is the third degree polynomial. We have x cubed, we have x squared, we have x, and we have a constant. Because here the degree is 3. The degree is 3. So it's a cubic factor. It's a cubic factor. I know that the degree is 3. Okay. Okay, now using the same method of comparing coefficients, you can find this. So there are two ways. I have told you. When you know one factor, you can either use comparing coefficients to get the other factor, or you can use the long division. So you should get the answer. You can use the long division even. Okay, so here I know how do I get x to the power 4. It's by these two. Since it's 1, this is 1. So that one is okay. Same drill. Okay, same drill. This one and this coefficient, you can write it directly. So both these coefficients, I can write it directly. So Avadi, what is the constant? Minus 3. How do you get minus 3? It's minus 1 into plus 3. How do you get minus 3? It's minus 1 into plus 3. So writing the first two coefficients, it's really easy. But when you have to write the these coefficients, you have to consider because here the coefficient is plus 2. And if you see, like, how do you get this x cube? You get x cube from this one and this one. So there are only two places that you get x cube. Clear? There are only two places that you get x cube. You get x cube from here and here. So you already got a minus 1. And what do you require is plus 2. What do you require is plus 2. So how can you convert a minus 1 to plus 2? You should have plus 3, which means x into this one should be plus 3. Clear? Because there are two places that we get x cube. Clear? Is that clear? The same drill like you did for this second degree polynomial when there's x squared plus x plus 1, you did it. No? Now I'm putting one step ahead. You have to write this in this case. Okay. And now when you look at this x squared term, the coefficient is 2 and there are two places that you get x squared. Okay, there are two places. One place is minus 1 into this. And the other one is this x into this one. So you can see already you have got a coefficient of minus 1 into 3 is minus 3. What you require is plus 2. So how can you convert a minus 3 into plus 2? It should be plus 5, which means this x into this x, the coefficient should be plus 5. So I have factorized it using the comparing coefficients method, that fx is equal to x minus 1, and I have written the other factor, x cube 3x squared plus 5x plus 3. So I have used this. I have taken this one and like same method of comparing coefficients. So what did I do? First I wrote the coefficient of this one and the constant. So those two are done. So then when you compare x cube, there are two places that you get the term x cube. One is minus 1 into x cube. So it's already a coefficient of minus 1. The other one is x into this x squared. Since I want plus 2, it should be minus 1 plus 3. So the coefficient should be plus 3. So that is even done. And then come to x squared. Then come to x squared. First look at this and identify the two places that you get x squared. There are two places that you get x squared. One is minus 1 into 3. So you already got a minus 3 coefficient. You need plus 2. How can you convert minus 3 into plus 2? You should have plus 5. What is the other place that you have this x squared is this x into 5x. Clear? This x into 5x. So that coefficient should be plus 5. So it's plus 5. But let's say someone says, I find this a bit confusing. That is totally okay. What can you do? Use the longer division and get this. But I like explain this in the simplest way. I hope that you understood. But in case I have even seen students, even though for this x squared, x and x1, even though I have explained this, still some of the students are doing it long division. That is totally okay because it's your simplification. So if you feel this is, I feel like this is a bit confusing, that's totally okay. Just go with the normal way. Go in the normal way. Use longer division. Okay. So I'll give you a small note. So when you're doing this one, when you're doing this one, like just write method 1 and just keep space. I'll be given a topic. Just write method 1 and then keep space. I'll be given a topic. Okay. And write this. A fourth degree polynomial. When we are factorizing a fourth degree polynomial, when we are factorizing a fourth degree polynomial, it can be done in the following two methods. It can be done in the following two methods. Okay. Then first write, let's factorize. Write fx equals to this. Let's write this one. Fx equals x to the power 4, 2x cube, 2x minus 2x plus. Okay. And then using a red pen, write method 1 and just keep space. I'll give it later and come up to this one. Come up to here. And after writing up to here, just put a message in the chat mentioning okay. So just write method 1 using a red pen, keep space and start from here. So I'm first finding a linear factor. So that is the main thing. First you need to find a linear factor. So whatever the method, first you need to find a linear factor. So first I got a linear factor, and then I have using the comparing coefficient method, and I have taken the other factor. But I'm mentioning, if you find this a bit confusing, even in this question, use long division. Never mind, use long division. Because I don't want anyone to do like simplifications, errors, because this method is confusing. If you just find this field is confusing, do in long division. Okay. Okay, now what you have to do is, now I have factorized this and I have taken one factor. But normally I know when I'm factorizing a third degree polynomial, I get a linear factor and I'm getting a quadratic factor. So then you can, if the quadratic factor gets factorized furthermore, you can factorize it. But here it's a cubic factor. Here it's a cubic factor. You can't factorize this furthermore. Sorry, you can't just factorize it. So what I'm doing, I'm taking this as gx and I'm separately factorizing this. So what am I doing? I'm taking this cubic factor as gx and I'm separately factorizing it. Okay, right? Gx. What is gx? It's x cube 3x squared plus 5x plus 3. Okay, now what you have to do, you have to take the cubic factor and you have to factorize it separately. So here it seems all are plus. I know like put in positive values doesn't make this 0. Since it's plus, put in all the positive values doesn't make it 0. Doesn't make it 0. So I'm putting a negative value. If you put -1, it's -6. Okay, I can see when I put x equals -1. X equals -1. I get g -1 is equal to -1 cube, 3 times -1 squared, 5 times -1 plus 3. So I get g -1, don't write it, give a small note, -1 plus 3, -1 plus 3. So it gives you 6 minus 6, which is 0. So you got x plus 1 is a factor. X plus 1 is a factor. 3x plus 1 is a factor. Okay, x plus 1 is a factor. So x plus 1 is a factor. Then you can completely factorize gx. One factor is x plus 1. Okay, what is the other factor? You got x squared, x and the constant. Here it's 1, so it's 1 and 1 you need plus 3. How do you get plus 3? Plus 1 into plus 3. And if you talk about this one, it's 3, it should be 3. So already you have plus 1. You got 2 more, you need 2 more. So if you want 2 more, this is plus 2x. Plus 2x. So you have written that gx is equal to x plus 1 x squared plus 2x plus 3. So you have completely, first we have factorized fx and taken it as x minus 1 gx, and then gx is a cubic factor. Gx is a cubic factor, then what you can do is you can completely factorize gx, and then you can write, okay, then what is hx? Look at this. What is fx? It's x minus 1. It's x minus 1, and I know gx, so I have completely factorized gx. What is gx? It's x plus 1, x squared plus 2x plus 3. Okay, so I have completely taken this x minus 1, x plus 1, x squared plus 2x plus 3. Clear? So this method, since we have used the factor theorem twice, we say that using factor theorem repeatedly, or even using the remainder theorem repeatedly, because The main theorem is remainder theorem and factor theorem is something that we are deriving from the remainder theorem. So this method is called using the factor theorem repeatedly. We have used factor theorem here once and again we have used it. Clear? So can I use the rational root theorem to find the value of x to substitute? What is the rational root theorem? Rational root theorem, I can't remember I explained something like that. Never just tell me like what do you mean in this? Okay, clear. So what do I do here? I find one linear factor and the other one is a cubic factor. And I can use the factor theorem again to completely factorize the cubic factor. So we get, this is gx. Okay, so if I take this as 1, and then if I substitute that factorization of gx in 1, I get fx is equal to x minus 1, x plus 1. And that one. Clear? Hands up if this one is clear. Hands up if this method is clear. Okay, clear. Okay, then in method 1, right, using factor theorem slash remainder theorem. Using factor theorem slash remainder theorem repeatedly. Using factor theorem slash remainder theorem repeatedly. Using factor theorem slash remainder theorem. Okay. So how did you get x minus x? This one I just put x equals 1 and this became 0. Okay, clear now? Okay, then you have come up to here. Then name this as gx. Name this as gx. Name this as gx. And then write this. Now we can again use, okay, now like name this as gx and right now we can again use the factor theorem. Now we can again use the factor theorem. Now we can again use the factor theorem to factorize gx. To factorize gx. Okay, factorize gx. Done. Okay, then do it and get the final answer. So this is the first way that you can do it. First method. Okay, so let's do the second method. And if you just look at look at these past papers. Look at the past papers in 2012. In 2012 past paper, I'll ask you to do that as a homework. Just turn to 2012 past paper, question number 15. You can see using remainder theorem repeatedly. So this is what they expect. Using remainder theorem repeatedly, show that x plus 1 squared is a factor. So even in that case, first use remainder like factor theorem and show that x plus 1 is a factor. So first thing, show that x plus 1 is a factor and they divide it, get the other factor, and then show that again x plus 1 is a factor. Then you will be getting it is a factor of x plus 1 squared is a factor. Same thing, okay? Same thing, you have to use it twice. Clear? Like when you do it, you will realize So they're asking you to show that x plus 1 squared is a factor. First show that x plus 1 is a factor, and then take the other one, and then try to find a factor of this other one. You will be getting that x plus 1 is even a factor there. So here we got x plus 1, and again we got x plus 1, then you will be getting x plus 1 squared is a factor. Clear? Okay, so you can do that as homework. So I'll explain the second method. So write method 2. Write method 2. Method 2 in this same thing. Write method 2. Write this finding two linear factors. So last one I'll be discussing in polynomials. Write method 2. Finding two linear factors. Finding two linear factors. Okay. So how can we do that? First, I'm finding one linear factor that I can get x minus 1 is a factor. When you put x equals minus 1, okay, you will realize that f minus 1, okay, now look at this, is equal to minus 1 to the power 4, 2 times minus 1 cube, 2 times minus 1 squared, minus 3. So I get f minus 1 is equal minus 1 to the power 4 is 1. Now this is minus 2 plus 2 plus 2 minus 3. So you realize these two cancel off and these two cancel off, and even you are getting that f minus 1 is equal to 0. Clear? When x minus 1 is equal to 0, you have another factor that x plus 1 is factor. So you have taken two factors. Clear? You have taken two factors. So what is the second method? That you can find two linear factors. Clear? And two linear factors. And now you know that fx is equal to x minus 1, x plus 1 times the other factor. You know fx is equal to x minus 1, x plus 1 into the other factor. So gx is the other factor that I want to find. Gx is the other factor that I want to find. Okay, then you can easily find gx when you divide fx by x minus 1 and x plus 1, you can easily get the other factor. If you can remember, this is where we started the class. Today we did this 2000 and I gave this as homework and I discussed today in the class 2011 whole syllabus paper. Same one, we had two factors. So when we have two factors, when we divide fx by the two factors, we can get the other factor. Okay, so then use log division, 2x cube, 2x squared minus 2x minus 3. I'm going to divide this by this. So this is x squared minus 1. Okay, so this is where we started the class today. You can remember the 2000. So this is x minus 1, x plus 1. The 2011 whole syllabus one. So after finding two linear factors, I know then fx is equal to this. So what is the other factor? It's fx over x minus 1, x plus 1. Now you can divide this. X to the power 4 divided by this one is x squared. When you multiply, x to the power 4 minus x squared. These two cancel off. There's no one to get subtracted with 2x cube. It comes down 2x cube. 2x squared minus minus is plus. It becomes 3x squared minus 2x minus 3. 2x cube divided by x squared is plus 2x. So when you multiply, it's 2x cube minus 2x. Again, no one to get subtracted from 3x squared. Minus 2 are these two cancel off, minus 3. 3x squared divided by x squared is plus 3. So then I have 3x squared minus 3, which is 0. I'm getting 0 because I know it's a factor. So then this is the other factor. This is gx. Clear, this is the other factor. The quotient is gx. Then you can write the complete factorization fx is equal to x minus 1, x plus 1, and gx. What is gx? It's x squared plus 2x plus 3. Can write fx is equal to x minus 1, x plus 1, and to the other quadratic one. Clear? We can use simultaneous also, right, to find in the gx. Yeah, same thing. Okay, so clear. So what I have done, I have used this one. I have taken another factor. So after taking another factor, then you know two factors. So here's your other factor. So when you divide it fx by both the factors, you are getting this factor. Clear? Okay, so do this. So second method is finding two linear factors. Do this one. Do it alone. So this is where we stopped in the 2000. We started at the 2011 one. Okay, complete the work. Get another factor, and then use the longer division to get the other one. Okay. Okay, so here from here we end polynomial, but then we will be having a polynomial unit test. Not next week. I'll tell you in next week classes. I'll tell you, and I told in the Shakti's class that next week we'll be having the class at 3 p.m. No, even in this month I'll be doing the Shakti class at 9 o'clock. I'll even send a message properly in the group. So students from Shakti, like convey the message for your friends. Next week we'll be having classes as usual at 9 o'clock at Shakti. Okay. So we'll be changing the time in July for this month. So in Shakti, we will be having the class on Tuesday, 9 o'clock in the morning, and COChem as usual, 3 o'clock in the evening. Clear? Okay, so make sure that you convey the message, and I'll put a message in the even in the chat in the group mentioning that we will be having classes as usual, 9 o'clock at Shakti. Okay. Okay, then we are done for today. You can stay safe at home.